Hi, 8th grade, and welcome to Chapter 9, which is quadratic functions. Today is our first lesson in Chapter 9, and we're going to be doing Lesson 9-1, which starts on page 534, and we're going to be looking at quadratic graphs and all of their properties. Our gotta check is going to be page 536, number 3, and our homework for today is going to be page 538, number 7 through 9, and 34 through 39. Our bell ringer is going to be page 540, number 55. So bell ringer in 3 sentences today. Okay, let's take a look at quadratics. This is our first day of quadratics, and we've been working a lot with expressions that had x squared in them. And our parent quadratic function, meaning the most simple quadratic function, the one that all others are based off of, is going to be our base function y equals x squared. Okay, so this is our parent. This is the mom or the dad or the parent. This one is the basic function that all the other ones are going to be based out of. Okay, when we look at the quadratic function, let's take a look at our parent function. So our parent function is going to look a bit like this. Okay, quadratic functions always have a very specific shape. So its shape is called a parabola, and a parabola is symmetrical, and it has a couple of important points. So here's some important points. This point right here, okay, which is in the middle of the line of symmetry, this is called the vertex. And our vertex point can be it can be a maximum or it can be a minimum. We're going to take a look at what happens. How does our parabola get flipped over to the bottom? Okay. Also, and maybe I'll just draw this in with a little dotted line just so you guys can kind of see what this looks like. Okay. A parabola always has an axis of symmetry. So there's always a line that runs down the parabola exactly symmetrical, and the line of symmetry is always a vertical line. So it's always going to be vertical, and it's an x line. In this particular case, the axis of symmetry for the parent function is x equals 0 because it runs along this axis here. Okay, so how can we make certain changes to our parabolas, and what can we do to give them different shapes? Okay, so I want to take a look at a couple of options here. All right, so first thing I'm going to take a look at is how do we flip our parent function over? So if this is y equals x squared, this is a happy face parabola, right? We've got kind of a smiley face. So how do we get the frowny face parabola? And the answer to that question is to get a frown, you have to be negative. So this would be the graph of y equals negative x squared. If we have a negative sign in front of the squared term, that means that our parabola is going to point downward. Okay, so in this case, our vertex would be a maximum point because that's as high as the parabola goes. Okay, what are some other things we can do to change our parabolas? Well, we can shift them up and down. So very much like we've shifted other functions before, let's say I want to shift my parabola up by 2. Okay, this would look like y equals negative x squared plus 2. Okay, it's negative because it's downward sloping in x squared, but it's plus 2, we've shifted it up. Okay, if I wanted to shift it down, okay, so this is an upward shift. If I wanted to shift it down, it would become x minus 2. So if I was going to do y equals negative x squared minus 2, what I'd end up with is a graph that would shift downward. So this would be at the point negative 2. Okay, so adding a term onto the end or adding a constant onto the end will shift it up or down. okay, whether you're adding or subtracting. All right. It's also possible to change how wide or narrow the parabola is. So let's go back to our parent function. Okay. Now, this is actually the opposite of what you'd think. So let's say I was going to take something like y equals 2x squared. Okay. This actually makes the parabola more narrow. And that's because the y increases at a greater rate. So that actually makes my graph more narrow, okay? If I was going to multiply this by some sort of a fraction, like y equals 1/2 x squared, this actually makes my parabola wider. So if I was going to have something like y equals 1/2 x squared, this would make my parabola wider, okay? Interesting, right? So let's take a look at the gotta check, okay? So our gotta check asks us to take a look at 3 functions, and they want us to put them in order from widest to narrowest. So our gotta check 3, and I'm just gonna put this in a small little spot here. It wants us to look at 3 functions. Y equals negative x squared. It wants us to look at y equals 3x squared, and it wants us to look at y equals negative 1/3 x squared. Okay, you put them order from widest to narrowest. Come back when you're ready. All right, let's put these in order from widest to narrowest. So remember, in order to make my parabola more wide, I'm multiplying it by a fraction that is less than 1. So this one will be the wider parabola. So as I take a look at these, negative 1/3 x, this is my fraction that's less than 1. So this is going to be number 1. This is going to be the widest. So this one is definitely the widest, okay? Next, I'm going to compare these two. So this one is negative x squared. This is pretty close to our parent function. And this is 3x squared. Well, remember, when I said I multiplied it by a number larger than 1, like over here, this actually made my graph more narrow. So that means that that one is going to be the narrowest. So number 2 is going to be negative x squared. That's going to be in the middle. And my narrowest is going to be this last one, y equals 3x squared. Okay, it's time to try your homework and match up some equations with some graphs. So remember, your homework is page 538, numbers 7 to 9, and numbers 34 to 39. Your bell ringer is page 540, number 55, and 3 sentences. All right, bye everyone, see you tomorrow.